Hello and welcome. I'm Bill Wake. We're working on Parser combinators written in Swift, and we've come a bit of a ways. We did a lot of spike work last week, and we're doing the kind of production side this week. We got the vertical bar working, so alternatives, and we got simple ands working, and we want to focus on errors because I'm worried that if we put that off too long, it'll be kind of a pain to get it right. So we'll do that today as well. Okay, let's see. I've got a scheduling conflict tomorrow. I have to go to the dentist, so I think I'll try and start us like an hour and a half later, and maybe go a bit later as well. And then I'm off next week. There's well, yeah. Let's just say I'm off next week. Theoretically, I could be back Friday, but we'll just say it's a week off. I don't think we're going to finish the parser combinator stuff before then, but I'm pretty sure that following week we should be able to get it done. So today we'll do our focus here. We've started to deal with failure, and one of the things we did was we said, okay, rather than just saying I failed, we want to return the position. How far did we get, or at what point did we detect a failure? Maybe is a better way to say it. And what's the message? So some things are returning this, some things are returning that, and our tests don't know what to expect. Okay, so we just got failure. So we've got parsers that don't produce the new style. Okay, and then with well, I think the characteristic. Let me do some changing around here. Okay, so let's look at our test. Look for one or two. Sorry, look for one, then two, sat one, then sat two. We're expecting one and two. We got one and four. We would like to say the failure point was here at position one. Okay, so actually that is what we're going to say there. Unfortunately, yeah, I don't know better wording here, but if the first item matches and the second doesn't, okay, let's actually swap these tests around. I think this is the simpler test. What did I just do? What? You didn't pass. No. How does that pass? If only first item matches. Oh, okay. First item fails to match. I don't know. Something's weird. Like, if it passed, why isn't it marked green? I don't think it passed. Okay. Now I'm happy. Okay. Let's consider this case. And then fails if first item fails to match. Okay. So here we've got 0 to 5. It's looking for 1, then 2. And it should fail at this point. It should detect position 0. Let's make it a different number so we don't mix up our zeros and our zeros. Okay, position 0 did not find expected value. Okay, I can live with that. This, okay, in here, so if our first one fails to match, let's extract this into a variable. Extracted expression is result 1. And I think it can probably infer the type without our help. Okay, so parse one. If the parse was successful, then we want to do some other stuff. If it failed, let's just return the result. Okay. I think that should be a step forward. Oh dear. Parser 1 is a parser with the input being the underlying type. And the result is an array. Okay, that's fine. Cannot convert. And then array p input. I'm puzzled. Parse result. Input. Target. But parse result on failure doesn't need either of those, so I'm not sure why that's not compatible. Okay. Well, what the heck? Parse result. Okay, let's see this thing. Parse result p.input p.target. Well, it's really a type thing, isn't it? Let's try this a different way. Switch result 1 dot success okay. If it's successful with these, do this stuff. I think. Okay. In this case, we want to do a return. Well, let's see. Return dot success. No, dot failure 2. I think we'll be okay with that. Okay. And then this is up there. And then I think if we take this out, we get a error. Yep. Okay, I don't think we should hit this because I don't think failure should happen. Okay, let's try that test again. Okay, oh, sorry. And I should say, I think what I did here was by creating a new failure 2, I'm switching it to the type of the parse result target here rather than the individual item I had up here, even though the arguments are the same. It's a different, this thing is of a different type. Okay, so this test fails if first item fails to match. Okay, yeah, I don't know if the message will be right, but I think the index will be right. Okay, um, why do I not trust it? Okay, did not find expected value. Oh, that is what we put in our sat parser. Okay, let's double check that. Did not find expected value. Okay, good. Now, so we don't need this. Okay, so if it fails to parse, um, the first if the first parser fails, then we just want the location is going to be the location of that first parser, and we'll take whatever it gave us and the message it had. Okay, but if the second one fails, we actually want to we want to say that we got further along. So we're going to look at remaining one. I think we have kind of a similar situation, don't we? Okay, let's get the test right first. Okay. 1, 2, we got 1, 4. We would like to be at position 1 here and did not find expected value. The message could be better, but I think we'll get by with it for now. Because we don't really know when the sat fails. It's just an arbitrary condition, so we really don't have a good name for the result. All right. If parse2 succeeds, that's fine. Otherwise, well, I think I'm going to put the same kind of switch statement here. Switch result 2. Case success target 2 remaining 2 colon. Okay, if it's a success, otherwise it's a failure, can't happen because we're getting rid of these. And then the third case is dot failure 2, let location, let's be explicit here. Let message 2. And case label, yeah, no statement yet. Okay. I'm going to call this location 1, message 1, just to make sure I'm clear in my head which thing is going on. Okay, so location 2, then we're going to return a failure. And once again, we have to switch the type to our result type. Location is that what we want? The message, however far it got? Okay. Okay, and message 2. Okay. So parse 1, try and do the second parser on the remaining. If the second parser succeeds, then the whole thing's a success. Return an array. If the second one fails, well, pass the message along. Okay, and I think this might not be needed. Oh, no, it does. We still don't have anything for this case. Well, let's add it in because we're going to delete it anyway. It'll reassure me that my case is exhaustive. Okay. And I'll just give a little breathing room here. All right. I think this should pass that test. Yeah. Okay. Now, let's see, to do make and return failure 2. Yes, that is done. Let's see, so we're doing error reporting. Make ampersand return failure 2. Good. Okay, delete failure. Yes. And we can just delete it here, and the compiler will tell us everywhere we used it. Most of them are in AndThen. Can't happen, return failure. And can't happen, return failure. Okay. Very good. Okay, so this is, I'm really happy about that. This did not find expected value thing doesn't thrill me, but that's okay. All right, so delete failure. We've done that. Okay, let's check this in. And then reports failure point as far right as it got. Okay, and then finally we'll do a rename. Failure 2 to just failure. Okay, well, it's really parse result. Right. Yeah. Alrighty. Okay, I guess this is still it's still error reporting related. All right, so satisfy. I don't know if this out of input is helpful. Let's make these the same. I think we tested it somewhere, but okay. All right, so what I'd like to do, well, basically I'd like to give this thing another parameter, and let's let it be message of string, and then message is type string equals, and let's give it this value. self.message equals message. And now we can use message down here. So we're still in a refactoring mode here. All right, on test should pass. Okay, so we did change message when out of input, and then we did refactor, add optional parameter, message to satisfy. All right, and we got some satisfy tests. Well, satisfy. I'm not sure this error reporting is really helpful. Okay, but let's redo these two tests and just demonstrate that we can pass the message parameter. Satisfy with message that fills and satisfy with message. Okay. If we make satisfy and we give it a parameter, my message, that message should be here. Same thing here. Okay, and the message is didn't find. And these I think I'll pull these two together, that I care more about them that way. Satisfy with default message. Okay, and this should pass. The way we refactored it made it kind of a new capability, but we've demonstrated it anyway. Okay. All right. Give satisfy an optional message. Good. Now, the next one, we're just kind of knocking through things. This is, well, actually, let's deal with this at the level of, how about alternatives like that should return best message. Where best equals largest index or the right if they're equal. Okay, so what I'm trying to say, this is an error reporting test, I guess. Okay, so test alternatives report best message. Report most successful error. Okay. I don't know, there's probably a better way to say it, but okay. So we're going to make a parser. Satisfy well, let's call it sat1 again, satisfy. I don't know if it'll infer it. $0 equals 1. Okay, and then we'll take result again. Oh, I'm going to make another expression. Okay, let expression equals sat1 and sat1. I guess we could probably give ourselves a little bit of a break here, make a sat2. Should be 1. Should be 2. Okay. So sat1 and sat2, or I just don't want to make myself too confused. I want to make sure my example demonstrates the issue. Let's do or sat2. Okay, so it can either be 1, 2. Uh-oh. Oh. That's probably, let's do it this way, sat2 and sat1. Okay. So you can either be 1, 2 or 2, 1. And we'll do, how about grammar? We'll parse grammar. Parse, and let's give it one. Okay. And so we expect to get a message about should be 2. Oh, I'm still not going to do it. Okay, let's make a 3. I'll set 3. Okay. So sat1 and sat2. Can I find sat3? Or sat3 and sat1. So I either want 1, 2 or 3, 1. And I'm going to pass the 1. Now, this one will get this far and then fail here before, looking for sat2, so should be 2. This one will get this far and say, you're not a 3, okay? But we expect, well, we've got expectations about the message, I guess. Okay, if failure equals result, okay, location message, we expect location 1, and we expect the message should be 2. Okay, and I think we're going to fail this test. I haven't looked at OrElse in a few days now, but let's see. I think it's going to report the second error. Should be 3. Should be 3. Okay. Yeah. So what happens is, let's find OrElse. OrElse basically tries the first alternative, and if it succeeds, it returns it, and then it tries the second alternative, and if it succeeds, it returns it, and if it fails, it returns it. So it always returns, the failure is always the second one. If it fails the first one, it tries the second one and then returns the second one's result. Okay, we're asking it to do something different. We got result 1, result 2. If it's successful, return it. That's fine. But here, let's do this. If case result 2 is successful, let's return that. Okay. Otherwise, we know that both result 1 and result 2 are failures at this point. And we need to return the better failure, the one that got further. Okay, so I think we want to say, oh boy, what do we want to say? I think we're going to have to, let's write a helper. Okay, so what I want is furthest result, best failure, and I've got 2 parse results. Parse result p1.input target. Sorry, this is failure 1 of that type, and then failure 2 of that type. And it should return a parse result of that type. Tedious, I know. Okay. And let's return best failure, result 1, result 2, and for now we're just going to return result 2. Okay, and this should failure 2. Okay, this should be the same result as the first one. Okay, 2 failures. Who's the second? Oh, in the same test. Okay, yes. All right, so, or else. All right, so here we want to peel these 2 apart. So if case dot failure, whoops, if case dot failure of let location 1, let message 1, and well, let's do a guard case, I think. Guard case message 1 and failure let location 2 equals failure 1, location 2 message 2 equals failure 2. Oh, I don't get to do these compound? Oh. Okay. Else, I'm just going to say if it doesn't come up with failure, return the other one. And then something similar here. I think it's really it can't happen, so I don't know. Okay, now we've got them both. All right. And what I want to say is if, well, I want to say return location 1 is greater than location 2, then failure 1, else failure 2. And just to prove I'm wrong, oh, what's the matter? Cannot find location. Location 1. I'm putting the wrong condition in here. And I guess I don't need these messages, do I? I'm not changing anything on them. I'm just returning one or the other. Okay, and I only need to look at the locations to make my decision. I'll put the wrong condition here, but it should be greater, but I'll just let it be. Okay. And my test should pass. Oh no. Should be 2. Oh, okay. I guess I have to spell it the same, don't I? Okay. Or returns best failure. One that got the furthest. Test alternatives. Report second error if location tied. Okay. And I think we can be simpler, but we'll just steal this for a moment. Oh, I already did steal it. Okay. We can probably, it's okay if we just fail at the first point. So let's just do that. Or set 2. Get rid of this one. Okay. Grammar.parse 3. So both fail. The message should be location 0, and the message should be the second one. It should be 2. Okay. And this should fail because I did the greater or equal. Okay, we got should be 1 and or else. Let's make this greater. And I believe we should pass. Good. Okay, so what I like about this, well, this is a little ugly, but what I like about it from this side, my sequences, they get further and further in, and they are compared. Sorry, however far you get is good. Otherwise, everything would be failing at the first character because the whole rule was not satisfied. So this gets us as far as we can go, I think. And we may have to tweak this later. I don't know if it's the ultimate solution on this, but I would say that's a really good step. Okay. Now, alternative should return the best message with the largest index of the rightmost message if they're equal. Okay, good. Now, this one, I don't remember if we implemented one of these or not. I don't think so. The idea is, like, sometimes, recall the basic grammar, right? I mentioned yesterday, you can have a print statement, or you can have a let statement, or you can have a if statement, or whatever. Okay, so it looks for the first statement has a keyword or allows a variable name, but once you've exhausted those possibilities, if you said, flugelhorn as the first word of your sentence, it's not going to match any of those. And there's no reason why the random last one is the best message, right? We would say, oh, you didn't match restore. Okay, well, who cares? I just want to say it's an unrecognized statement. So the idea with the message one is it's gonna act sort of like an or that, but if this parser if it succeeds, we just return this and we don't look at the message. If this fails, we're going to do a message. It's going to be like the or that we take the starting index, but we want to if this one actually got further than the start, we want to let its message come through. So if you had x equals 3 plus 4 plus, okay, you didn't put your last 5 that you meant to, okay. That's practically an assignment statement, and you got up to position 4 or 5. That should beat out this message. This message is really only, well, it's only for the case where you just didn't get down any path. So if all the paths got exactly the same distance down, usually 0, then you want to return that message. Okay. Now, there's some duplication we can see coming in because this best failure idea is going to matter. Well, we shall see. Okay, so I think we have a new test type. Let's go here. Oh, we didn't check these in. Let's make sure this is... Okay. If all messages on have the same location, you use the rightmost one for the message. Alrighty, and let's make a name. New file. Now, last night, okay, here's my theory. If I select this and hit next, I'm going to get a chance to name it. No. Okay. Let's try again. New file. If I double click it, no. Okay. I swore I had it working once yesterday. One more try. New file. Let's try switching back. No. Okay. I don't know. Something that's an Xcode bug in my book. Okay. Usually it says next and it prompts you for the name of this thing. Okay. Name tests. All right. Now, I don't know. Okay, we'll borrow the front half. It's so similar to OrElse, I hate to make any duplication on it. But it is different. Ugh. Oh. Okay, the real thing is it needs a parser, and then it needs a string. So it's a new class, no doubt. It's just so darn similar. Okay. Name tests. So let's make one. Test name not used if parser succeeds. All right, that should be the easy one. All right, so we'll make a parser. Sat1 equals satisfy should be 1. And $0 equals 1. Okay, and let grammar equals sat1. Well, let's do it. No, we'll do what we want. Sat1 colon. Oh, let's do it this way. Let's take the default here, and let's put the name here. Okay, so if we had a parser like this with an unsatisfactory name, then we can update its name. Okay, and maybe a sat2 would not hurt either. How about this? Sat1 or sat2, and or else give it this name. Okay. Yeah, we don't have an operator yet. Okay, but this is the kind of thing I want, because I want let it grammar is, print or read or restore or this or that or the other thing, or unrecognized statement. Okay, so this is the analog of that. All right, and then I think we're going to need the reporting tests we just had. Well, no, not for this case, right? So let result equal grammar dot parse, and one. That should be successful. If case success of let value let remaining equals result. Otherwise we'll do a fail. If we succeed, we'll assert separately. Okay. All right, and assert equal value should be 1, and remaining, what the heck, should be empty. Okay. I think because this is messed up, we're messed up. Okay, and then or else, let's we're going to want the same kind of precedence as that. Function, let's call it colon. Hope that's legal. And precedence is right, but we need a name. And this is very much like this. Well, let's just take the whole thing for now. We're getting named us. P parser is a parser. I don't think we care about that. Okay, conform to stubs, yes. This is p.input. And this is p.target. Okay, so we're not changing the type of anything. Okay. And we got more stubs. Parse method. Come on. Well, we can run a parse method. Input goes to input target. And let's just return a failure for now. Okay. And I guess we'll need the parser. Let parser of p. Okay, we'll comment out our inspiration here, but we're just trying to get our test to fail. Okay, unary operator cannot. Oh, I can't use that. Can I use this? No. Oh, what else? I had such high hopes for my choices here. Let's see. Got notes from other papers. I don't know. I thought a colon was pretty darn good. Let's see. My well-organized collection of junk. I mean, we can make up another one, but I'm just trying to find one that's been used elsewhere. Well, how about at? At P of parser, parser P, add is not allowed in operator names. And yet you couldn't be that clear with the colon. Expected precedence group. Expected precedence, yeah, okay. At is not allowed. Exclamation point. Oh, it's already a unary operator. I can't use it. Oh. Percent? I don't know. Backslash? Yeah, let's try percent. Okay. And then what's going on with this one? Or else. This p parser, oh, goes to. Goes to name of p. Unary operator must have prefix or postfix. That's unary? I thought it was mod. Okay. Jeepers. I didn't know this would be the hard part. Yeah, it's a remainder. What's going on? Unary operator. Infix operator. This. Let's do a build. Unary operator implementation. Okay, I'm gonna make it plus plus for a minute, or bar bar. Since it's sort of else-like, maybe, or what? Unary operator. Must have a prefix or postfix modifier. I don't get it. No, plus plus used to be unary. Build field. What the heck? Parser P. Well, actually, I want a. Do the names matter? Not really. Parser P in a name of string. Maybe that's my problem. I didn't define two. I only had one parameter, so it looked unary. Okay. All right. And so maybe this will work again. Maybe this will work. No. that's easily fixed. Okay. Get the test to fail. Okay. Sometimes that takes a little longer. Okay. Should be success 1, but was 100 question mark. Okay, because we hard coded that result. All right. So name, let's go back to my description. Well, if it succeeds, we just want to return it. Okay, so we're just going to run the parser. Okay. If case.success equals result, return result. Okay, and now this should pass. Okay. Then if it fails, name is used if parser completely fails. That's what I want to say. Okay, so let's do sat1 and sat2 or sat2. Oh, our type stuff. Or sat2 and I'm just not going to fight the types right now. Sat2 should be 1, 2 or 2, 2. And we'll pass in a 0. Okay, and if it fails, okay, if the result is, well, location should be 0. Location should be 0. Because neither sat1 nor sat2 likes the first entry. And the message should be 1, 2 or 2, 2. Okay. Again, this is going to fail because we hard-coded a result, so it's got almost no chance. Okay, yeah, we got 100 question marks. All right. Let's go back up. Okay, so if it's success, we returned it. Otherwise, well, let's make this a switch. Switch result. Case success. I think we can just do like this. Return result. Case failure. Let location. Let message. We'll do something else. Well, right now we're doing this. Okay. This should feel the same way. There we go. Okay. All right. So if we get a failure, let's use Oh. How did I not? This is weird. My operator is returning name. Oh, it should be parser and string. Name. Okay. It just ignored it. Interesting. Okay, but if we go here, this should be name, type string, and name of type string. Self.name equals name. Okay, and then we can return input.startIndex and name. Okay, so if we get a failure back, we're changing it to start index and name. So 0. It's not quite the final version, but okay. And let's see what we get. All right. Happy it passes. It just seems so fast. Okay. Yeah, so we force this message in. Now we got one more case. Name original. How about name uses original failure if partially parsed. Okay, so we have sat1, sat2. Let's just give it sat1, so it'll succeed this far. And we'll just want to return failure 1. Okay. That will be interesting. Okay, so this message won't apply. All right, so what we expect is the location should be 1, and the message should be 1. Should be 1, then 2. Okay. And location 1. So it gets this far. Let's give it a completely, obviously wrong value. Okay. Sat1, sat2, or sat2, sat2. Should be that. Okay. That, I believe, will fail. Okay, we got 0, and this should be, yep, should be 1222. Okay, that goes back to this, and I guess if location, how about return location equals input.startIndex, then we return this. Otherwise, result. I don't know why it doesn't like my formatting, but I like it better this way. Okay. Oh. I guess we'll take the original. And again, I think we're kind of unifying types in a way that lets it know the right type. Okay, so is that enough? Immutable value location was never used. That's not true. Okay. So I think we're dealing with the best result thing here. Because we don't have two separate results, we don't have to worry about the best so much. We're just saying if you didn't make any progress, then let's use the name. Otherwise, we'll take whatever progress whatever progress you made and use that. And I don't know. Let's run tests. I almost want to flop my conditions around. Oh, okay. Did not find expected value. Oh yeah, well that's true. It's this parser that failed. Okay. So should be 2. But if we didn't get any of these, we say that. Okay. Now I think it'll pass. Okay. But I do want to swap these around. Okay. I'm going to say if the location is greater than the start index, that means we made progress and we should use the failure we had. If it's not greater, then it's less than or equal, then, well, it can't be less than, but we'll keep this the way it is. Okay, so if we made progress, our failure message is going somewhere, we'll use it. If we didn't make any progress, we're just going to use the name. All right, and where do we end up for operators here? I guess we don't need this junk. Wasn't as inspirational as I expected. Okay, good. Run those tests. Okay. Add name with default name for failed alternatives. We're due to do some of that, aren't we? Okay. This is %. If P fails failure, then return best failure. Okay, that's true enough. All right. Let's backfill documentation. We've got 3 or 4 parsers now. Let's get them in there. Okay. Then I think we're gonna move. Well, I want to just start knocking out more combinators. We haven't spiked these, I don't think, but optional. I don't know if it'll let us use question mark. I think maybe we have to use slash, but I don't know if we can use slash as a prefix operator. Interesting. Okay, we'll figure a name out. But 0 or 1 is optional. Then we can have many 1, which is 1 or more. And then we can have many, which is 0 or more. And finally, comma, which I hope that works, but I want to say A comma B means A and many more B comma, B A's. Okay. This is for things like a comma separated list of expressions. So you would say expression comma B, or expression this thing comma, and it would throw away the commas and keep the A's, a list of those, but it's requiring the comma. All right. Which means we may want to get this write only operator here. Another one I thought of was peak. There are occasions where we want to say, like, if the next token is like a legal start of an expression, then go do this, otherwise go do that. And we want to peak and not return anything, but sort of fail if it fails. Okay. Return the failure. I guess I could be more explicit. Okay. And I think we also had pipe, recursive, and we had wrap, and I don't know if we need it anymore. We were using it because the way I'd screwed up the OrElse is we couldn't really get, we couldn't really wrap the types properly or compose the types properly. Okay. Well, that'll give us a starting point. We're due for a break. Let's make a 3-minute break. We'll come back, do some documentation, and then knock out as many of these parsers as we can. Combinators. All right, see you in about 3 minutes. Welcome back. All right, let's go ahead and do this Readme a bit. We've neglected it so far, but we've got several parsers now, so let's make them work. All right, so this package is okay, and then my MD's been a while now. Let's see. So basic parsers and combinators. All right, and then I think, is it second level? Okay. Our only basic one is this, satisfy. Oh, we probably have to explain the parse result too. Parsers structures. I don't remember how to. I have a markdown thing somewhere. Markdown editor. I don't know. We'll get it sometime. That seems all right. All right, and the first one is satisfy closure over $0. Okay. We evaluate that as a Boolean and tells whether the first element of input succeeds. Okay, anything else about this thing? Oh. Okay, combinators. All right, this one is the alternative. Low precedence. Excuse me, if either parser succeeds on failure, returns the failure with the farthest, I don't know how to say this, returns the failure that got the farthest. We use the result of P1 if it succeeds or makes any progress. Okay, I think that's all right. And this is sequence, higher precedence. Well, let's see. We've got several rules going on here. P1, then P2 returns an array of results if they have the same target type. That way. Okay, and then anything else? Okay, that's not bad. Let's do documentation. And if we make a point to keep that up to date, that'll work better for us, right? Okay. Let's see. What's next? These are both useful for sure. Um, I don't know. Optional. Optional is kind of funny. Let's put it off a minute. I think this many one operator is a good one. Okay, so this one is you want one or more of something, and you know traditionally it gets written with a plus. So you say like expression goes to term. Well, that's not the mini one. Well, depending how you do it, but let's see. Can I think of one where you have to repeat things? Well, let's just make up one. Let's say A, then B plus. Well, normally you'd write it just A, B plus. Okay, in regular expressions or in grammars. And you've got this postfix operator that says repeat this. And it could be, you know, BC plus parenthesized or something. And it's postfix. But then you end up trying to read it and it's like, I want A, then one or more copies of BC. Okay, and so you end up looking for the operator at the end. I'm going to change the way the grammars work and I'm going to say this should be a prefix operator. Why was it not a prefix operator? And we'll see what happens. Okay. I'm trying to think of an example of a many one. If you declare an array in BASIC, you say like dim a sub 3 comma 5. You've got to have at least one dimension. I guess that's not really helping, is it? That's not a true case. Well, is it so useful? It's certainly the case that many is plus optional. Okay, something like that, or optional plus. Okay, so if that's a prefix operator, if you want to say zero or more, you can say 0 copies of one or more. Okay, and so if it fails the one, it's okay. Yeah, let's do it. Okay, so oh, sorry. Hey, D. Raj. Okay, yeah, I bet. So we're writing a parser. I'm trying to use this functional programming approach called parser combinators, and we're in Swift, which has some functional aspects, so we can kind of get by with it. I'll just kind of do a quick tour from the top, and then jump back in on the next feature. So probably the basic thing is there's a parse result, and when the parser runs, it's going to need to know an input type like characters or tokens or something like that, and then a target type, like what thing are you producing when you parse it, which could be expression trees or numeric values or something. So if you have a success, that means we parse something and we have a target value, which could be the input type as well. And then we also get the rest of the input. So when you call parse, you're giving it an array of input or a slice of input, and it's going to produce a parse result that has the target type and the rest of the input if it's a success. And if it's a failure, it's going to have where, like what column, well, it's which array entry in our slice had the failure point and what's the error message. Okay. So kind of the result is we either find out it succeeded or failed, and we get good information in either case. And all that is controlled by the parse. The basic parser is called satisfy, and what you're doing is you're passing in a condition, which is a closure statement. So it's like a Boolean expression. So if I wanted to see if my parse value matched 1, okay, I could, don't worry about the message, but I have a condition that says $0, the input value, equals 1, and returns a Boolean. Okay, and when it tries to run on your input, it's going to look at the input, and if the condition, the closure, says it succeeded, then it's going to return success. Otherwise, it returns failure. So it's kind of a one item match. Okay, and it it conforms to this parse type because it tells us your input is this type, and the output is the same type. All right, and you can see that the input here is based on that input type, and the parse result is also based on it. Okay, and you either get a success, or you failed to match, or you ran out of input, which is also a failure. And that's really the only parser that knows how to move forward or do anything. All right, everything else is what they call combinators, and it's built up. And so if I want to say match is a 1, okay, then I put value equals 1. Let me get a test that'll show that. Okay, here's a satisfy. $0 equals 3. Okay, so he's trying to match a 3, and we give it good input that has a 3 right here. He says, okay, I matched the 3, and the rest of the input is the rest of the array. And if you don't match, so we're looking for 42, but we find 3, we get a failure that says, at array slot 0, we did not find the expected value. Okay, and so that's the core of it. Then we get to these combinators, and a combinator says, hey, give me 1 or more parsers, and I'll build up an expression that uses them. So let me go to OrElse. I'm going to go down to the bottom because this is kind of the way we want it to look. So I made a satisfy parser, and I think it'll infer this type. I think I can cut this out and make it a little easier to read. Okay, so sat1 matches a 1, sat2 matches a 2, and this parser says or else, sat1 or else sat2, and if you give it the parser built up from these two things, it tries the parse. It says, is it a 1? No. But let me try the second choice. Is it a 2? Oh, yeah, it is. Okay, then my result is 2, and here's the rest of the input. Now, the implementation of that, there's a class called OrElse. Basically, this operator creates an instance of OrElse that takes 2 parsers. And so you feed in 2 parsers, and it knows how to run them both and come up with the answer. So here's the initializer. You give it 2 parsers, hopefully with the operator, because that's the easy way. And it tries to run the first parser. If it succeeds, it returns that result. If it fails, it tries to run the second parser. If it succeeds, it returns it. Okay. If it fails, well, we figure out which failure got further and then return that. So if one side made some progress but then died, that's a little better than making no progress. All right. Then there's the and parser. And is it also takes 2 parsers. And let's go to a test. And again, I'll go to one at the bottom. So if you say A, this parser, then that parser, I'm expecting to match a 1, then a 2. And so if I match 1, 2, 5, well, I'll build up an array of the results and I'll give you the remaining input. Okay. Now these inputs, they could be characters, they could be tokens. I just use numbers just because it was convenient to type them. But I don't care what the input type is. It's it's parameterized over that. So we basically have or and, so, alternatives and sequence. The piece we're missing is repetition. So I don't know if you know regular expressions, but, basically everything comes down to match a token or take a choice or match 2 things in order or match a bunch of things, repeat it. And so we haven't implemented a repeat one yet. The last thing we did, though, was this name thing, which I don't know if you were here for that, but basically this lets you put in a name string on after a series of parsers. So if we're saying look for 1, then 2, and they both fail, then I want to get the message should be 1 or 2. Okay. If one of them succeeded, I just take the success. But if this lets me put my own error message in if I want to. And I also see we didn't pull it out to its own class, so we'll do that. And then we were just about to start in on a repetition. So something that says you got to have at least 1, and if you have 1 or more, it's fine. Okay, so let's extract this class. I just implemented it in the test class for now, for starters, but that's okay. Whoops, that goes over there too, but we'll get it later. A new file. This thing isn't acting right. Yeah, okay. This is name. Public class name, and I missed the operators. Okay. Down here. All right, and this should pass all tests. No, I'm happy to have somebody new coming in, so thanks for joining. Okay, so we extract class for name, minor cleanups. Okay. All right. So now we're to the point I'd like to test this mini parser, many M-A-N-Y, not M-I-N-I. I'm hoping I can make this a prefix operator, and it says you must have 1 or more of whatever we're talking about. Okay, so, and this is going to be a bit like AndThen. And our AndThen, I don't know, there's a lot more to do here on this one. We won't finish it today. Oh, before we go, I have one more thing I notice. If I can let the I don't need to define this initializer because normally my normal case I'm using these operators, and I can let the default constructor take care of this, I think. So let's try that. There should be a handful of tests that don't have the name parser 1, parser 2. Yeah. Okay. Parameter P. Is that going to do it? No. Because no inaccessible. Oh, default initializer is not. Okay, let's revert that. Yes. Okay. since it only takes a few seconds to run tests, we'll just run those tests. They're nice and fast today, aren't they? Okay. Let's see. So the many parser, let's define a test for it. New file. This is many tests, many one tests. And all these tests kind of start the same with this stuff. Okay. So we want to come up with a situation. So function test. This is many one. Okay. So we want to test many one with one match. All right. And I'll just say throws just in case we need anything. All right, so let's let the grammar be. And this is where I'm going to find out if my my theory works. Well, let's get sat1 first. Is satisfy $0 equals 1. Okay, so we're going to match one or more ones. And I think we can just say it like this. Repeat sat1 multiple times, and then result equals grammar.parse of 1112. Oh, I guess we said one match. Okay. And we're going to do some checking. And unfortunately, the checking is a little tricky. Let's see. I just have it on GitHub on my, I think it's private still. I'll probably publish it when I finish. I don't think it's necessarily the best package for real heavy use or anything, but you know, to see what's going on, it'd be worth doing. Let me make a note of that too, because okay, so just down on my task list here, publish it. Not private on GitHub. Okay. And actually, one of these days, we need to check that our library actually is shareable, even on my local machine. We haven't done that. Try the library locally. Okay. Yeah, and yeah, I think that's worth doing. Good point. Okay. This, and now the test, the match. Unfortunately, they're well, okay, we have check success. Let's go see that thing. I guess that's a generic function, so we get to use that. Okay, so we'll use check success. Check success result and target and remaining input. Okay, so check success result. We expect to get a 1, and the remaining input is 2. Okay. And as far as implementation, I'm implementing this in the local class here while we test it, and then we'll pull it out. But this bit is going to be very much like this bit. So let's just steal it. Okay. Addition parser. Well, this is prefix precedence? No. What if I just type precedence? Default ternary. Yeah, I can say it like this. Prefix operator. Okay, I'm gonna look. just want to see the example. Ugh. How about Swift precedence levels? I know we've searched that. There is a page. The prefix operators, the postfix operators. Well, maybe don't specify one there. Oh, only infix operators may declare. Okay. Yeah, so prefix plus. Okay. You give it a parser. There's no name string. And we're going to produce a many1 of type P. And this should be many1 of the parser. Okay, so I don't know. I know you can get buried in user-defined operators, so I hope I'm not burying myself too badly. All right, cannot find type many1, prefix, func, okay. And we need a class. And again, I'm going to steal. Well, maybe this one's close. Parser, blah, 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 blah. Yeah, we'll just steal that whole bit. Okay, this is many1. The input is p.target. So given a parser, the input type is whatever that parser takes. The output type, well, we're going to make an array of whatever output type the parser has. So we're turning a parser, like maybe returning characters or numbers in our case, into a parser that returns an array of numbers. Okay, so we don't need a name. Input, b.input. Input. Okay, parser this. Name. I'm just trying to get the stub of stuff here, and all this is, we'll just return a failure for now. And I don't know that that will be useful stuff. But this is our stub anyway. So many1, you give it a parser of some type, choose the input type, choose the result type, store the parser, and then when you use it, we always fail. Okay, so our test should fail, but it should compile, so that's progress. Failed. Okay, we got our weird result back. All right. So we're doing the case with one match. So to do a match, we're going to get the result of parser.parse with the input. So we're taking that inner parser, get some results from it. If it succeeds, well, if it fails, return it. Okay, let's get values of type. It's going to be an array of target. Okay. Equals nothing. Oh, I think I can just say it like this. Empty array of targets. Okay. If, well, if case dot success of let value and remaining, Okay, remember that's what the parser returns in this case. If we find those things, then we want to return our own success, but now we change it into an array of values, and we'll keep the same remaining. Okay, if it variable binding equals result. Okay, so set up an initial array of values. Well, we're not actually going to use it. Let's just comment that out for now. Okay, run the parser, the original parser. If it succeeds, we've got one value. That's what we want, one or more. So return that value as a success, and otherwise return failure because we got to have some sort of return. Okay, I don't think this stuff's going to be that useful. All right, and this should pass our test. Okay. Let's test many one with no matches returns failure. Okay. So if we try to match a 1 and we don't start with a 1, this is a check failure. The result, and we expect a failure at location 0 in the array, index 0. And I think it's did not find expected value. Okay. This will fail. It'll get a failure all right, but it'll be the wrong one. Okay, failure is question mark instead of did not find expected value. Okay, well, that's actually okay. Back here, let's change this to a switch. The deal is we had to create a new failure because the type of this is, I'm a result type of some target value, and the result type of this is I'm a result type of array of target values. So that's why I'm going to have to fetch the values out. Switch result, and then guess this part's the same. That's the one case. And then case failure. And I'm not even going to look at the contents for now because I'm just going to return this. I don't know. I'm doing a refactoring while red. It's a little odd. But I'm trying to get the same error message. Yeah, thank you. Okay. One failure. And it's the same one. All right. So now we want to pull that failure. We like the location. The location is all right. Okay. We just need to use them in a properly packaged return type. Okay. So if our parser succeeds, then we return success with an array of values. If it fails, we return the location and message, and this should pass. Good. All right. Now let's get a many one with multiple matches. Okay, so And I think usually I try and tell a story with the tests. And I think saying, oh, you match once, you can match multiple times, or you fail. It's a better story. But I don't know. You could do them in the order you thought of them, but I think I normally try and arrange them. Even though I wanted to do the failure implementation first because I wanted to make sure that path was covered, that's still okay. All right. So now, if we have one or more sat ones, I think we could. Sometimes the types get a little messed up with arrays versus single types, but let's just do sat1 or sat2. Okay, so I'm going to allow for multiple items, either one or two. And that should be that, and this should be 1, 2, 2, and the thing should not bother with 3. Okay. This should fail because it only tries to get 1 back. Okay. 1 is not equal to 1, 2, 2. So it only pulled the first one because that's the way we implemented it. Okay, so now I can do this values thing. All right. Well, here let's do values.add value and return values. Okay, same failure. Oops, I always do this. Var value. Whoops, what's going on? Many1p target. Okay, array of array. Oh. Target's already an array. Right, okay. Yeah, and I'm, oh, still not happy. Oh, append. Okay, so multiple matches still failing. Same failure. All right. So somewhere there's got to be a while loop, right? And maybe we have to break this up into 2 stages. So I'm going to pull this out. Okay. Remaining is out of scope. Ugh. Let's do last remaining equals input. And let's capture that too. Okay. We've got our result value. We keep track of the input. If we make a successful parse, then our input update, our remaining updates, and we accumulate a value. And this again should pass all but the 1. But now I want to do a result. So this is the first one, and this is the required one, right? But then from here on out, I want to do a loop. Let's rename this first result. Okay. So here out, result is parser.parse of last remaining. Okay, so we're picking up where we left off here. And then can I say while result? I don't think I can say this. Not equal failure. Do something. Are you going to buy it? No. Okay. Let's see. What's a good way to loop this thing? Can I say it the other way around? Cannot convert type partial to expected type dispatch timeout result. Is there a while case? Okay, thanks for joining. Yeah, hope tomorrow I'm going to be starting a bit later, and then next week I'm off. But if the week after that, if you're around, love to see you again. Thanks. Bye. Okay, I think there may be a while case. Do we have that here? That flips this around, and we do success equals result. Good. Okay, and then I got to remember to do this at the bottom of the loop. Good old while loop. Okay. If I get a success, I want to keep going. Okay. I can pull these values. Let value and let remaining. Okay. So in the loop, I have access to those, and I just want to do the same thing I've been doing. I'm going to append the value and update the remaining. Okay, so if the loop fails, if I try and parse it and I get a failure back, well, it's still successful because I had the first one, so I just return success. If it's not a failure, it's a success, so I'll append the value, accumulate the value, and update last remaining. So I parse from there. And yeah, I think that's okay. So I'll update the values, and then I'll try the next parse, and if it succeeds, then we keep going. Okay, so I don't think that's too bad. Now I expect to pass. Forward test, yeah, you're still not running. Oh dear. Okay, what's all? 1 is not equal to 122. Multiple matches, sat1, sat2. Okay, let's see the code. Parse. We'll get the first result. If it's success, we do this and break out of here. If it fails, we just fail. Okay. Then we parse again, starting where we left off. And okay, well, let's break here. Okay, so let's see what last remaining is. 223, that's good. Let's look at parser. It should be an or thing, right? Or else to satisfies. Okay. If I step over, it should parse. Okay, what's the result? Is it failure? Let's see values. Okay. Parse and last remaining again. Yeah, it should be 223. Boom, boom, boom. All right. So, why is that result failing? Okay, I don't know. So, what I'm going to do is I'm going to simplify the test. Let's just, well, we'll copy this guy. Let's just take it on sat1 repeated, and okay. Well, I think 2 will be enough to prove we're happy, and 1 value outside is enough to prove that. All right, we'll just simplify the test for now and run with it. Okay, so last remaining is 1, 2. That's what we expect. The parser is that sat1. Okay. And we'll step over. And then result is success. Well, I mean, that seems to be going well, so let's just continue. Yeah. Okay, I don't know why it didn't work the other way. Let's do mini one with multiple parsers, multiple matches. Okay, so let's get our sat2. Grammar is this or sat2. Well, now I'm in an experimenting mood. Let's take this out for a moment and run them all. Let's check in what we've got first. Take this away. Continue. Okay. Add many one parser that can repeat one or more times. All right. And all right. What is going on with this thing? Okay, so now we have sat1 or sat2. And let's do this. Check success 112 returns remaining 3. Okay, so I guess first let's I'm going to throw in some extra stuff here and see what happens. Sat1 or sat2. We'll call that the grammar. And let's make it parse 2. 2. Okay. If we oh yeah, okay, that thing should only do that. It only returns one result. Only can match the first one. But it should match 2. Okay, so sat1 or sat2 should match this, and the remaining values are 1, 1, 2, 3. This should pass. So should the other one, by the way. Okay, so sat1 is happy doing that. Let's take off the 2 and just return a 1. And this should pass too. Okay. 1, 1, 2, 3 should come back with 1, 1, 2, oops, and 3. Okay, this one should pass, but we think it's going to fail. What? I don't know what I messed up before. Okay, sat1 or sat2. 1, 1, 2, 3. Should find the 1, 1, 2, and a 3. Okay. Did it run all of them? That was so fast. Let's clean test results. I don't know. It's sad when you don't trust your IDE completely, but I don't trust my IDE completely. Okay. I'm glad you're so fast. This is supposed to work, so I don't know why it wouldn't, but okay. Let's extract class. Well, let's add that. Add more complex test case for plus. Okay. Let's pull this out. Oh, there's duplication. I don't know if I can get rid of a lot of this duplication across my classes. It's so buried in types. We need a many one. Okay, so let's make sure that refactor's good. Yep. All right. We do support. Well, this was refactor. Refactor. Extract many one dot swift. All right, and let's keep up with our recommendation on documentation. This is many one. Well, it's one or more. I guess its official name is many one. Many one prefix operator. Um, okay, so plus P returns an array of one or more values if the parse succeeds at least once, else returns failure. Okay. Let's see. What's our next thing? This is good. Prefix operator, yes. Return array, yes. Now this goes here. And documentation now is a standing story, okay? It's required for anything else we implement. We're going to keep the documentation up to date. Alrighty, let's deal with, well, I don't know, many might be more interesting. I only got 7 minutes, so I got to pick the one that's going to be the fastest. Okay. I think that will be good. It's start with a test. And I kind of want to start with 3 tests, very similar to the tests that I started with before. New file. Many tests. Okay, and it's going to be very similar to this. Really, that's how you alphabetize. Okay. So similar. I'm just going to take the whole thing. Okay, many tests. And we're going to rearrange it. Because it's simpler. Many with no matches returns empty array. Okay. So we got sat1 and we try and parse 212 and this should be a success. The result should be an empty array. I don't know if it'll infer the type, but we'll hope. And the remaining values should be 2, 1, 2. And we will comment out these tests. Okay, and the notation for this one, we want a star. Okay, so 0 or more sat1s. And this is equals int nothing. Okay, can't find operator that. All right, let's pull this thing. And I don't know, again, I'm going to pull this. There's a little duplication. I don't know. Excuse me. Oh, no, I guess I'm okay. Mini, it takes parser. Input returns array of this and saves the parser. And let's just return a failure for now. Failure first. Let's just random stuff. Okay, that should fail that test, right? Oh, and we put our definition of our thing here. Parser is a many parser and a many parser. Okay, we'll just run these. Okay, result was failure. Okay, and we can kind of quickly return well, we can make a quick successful return. Successful return, empty string, and the input. Okay, so this should pass because the star operator, it always succeeds, right? Because if there's nothing to match, 0 or more is acceptable. So 0, an empty array. All right, now let's move on. Many with one match. Okay. Parse many sat ones, and if you have one, you match it. Good. Okay, and this always returns empty, so of course that fails. All right, now we're going to get a little fancier. Okay, so we're going to start borrowing pieces up from this. I guess at the end, return values last remaining is going to still be okay. Okay, values equals target. Yes, we got to keep that. All right, last remaining equals input. Let's keep that. Okay. The difference is we don't need this first case. Well, I may be overexcited about it, but I think we just want to do an attempted parse. Okay. And while we succeed, we'll capture the value and store it in there. If we fail right away, this never gets executed and values is empty and last remaining is still input. Okay, so I believe this should work. I think it will work for all our cases coming up. I may be 5 minutes proving that, but we're almost done for the day. Before the clock runs out, I should show this, right? Tomorrow, starting 1.5 hours late, which is 11:30 Eastern Time or 4:30 p.m. UTC. Next week, no sessions. Okay, but let's see if we can finish the many operator today or finish testing it. Okay, a many with multiple matches. 112 sat 1. That success should be the same. This should run. Good. And this one. Again, we're doing a star. Make sure I did a star on that one. Yes. Okay. So this is many with multiple parsers, multiple matches. So sat1 or sat2, 0 more times, should find these 3 and leave off there. Actually, let's make this one test the empty array thing. I think it's not going to build. I think we're going to do the empty values thing again. No? Okay. All right. So we've support the many parser star. And we'll need to extract that. Here's class many. Down to here. Many.swift. How funny. Many tests comes after many one, and many one comes after many. Many.swift, and the body is this. Okay. All right. Refactor. Extract many.swift. Very good. Oh, almost, I should say. Back down on my documentation task again. I don't know, maybe star comes, 0 more sounds like it comes before 1 or more, doesn't it? Many is 0 more. Star P returns an array of 0 or more values. All right. Well, I will call it a wrap for the day. Whoops. We will pick up tomorrow and attempt to do the remaining operators we're talking about. 0 more prefix operator. Yes. Return an array. Good. So we'll do this optional one and the comma separator, a bunch of variations here and a peak. I don't know, we got 8 or 10 to do more, so I think that's at least a few days work. But we're moving along. All right. So again, I start late tomorrow and off next week, but thanks for joining today, and I hope I catch you again in the future. Take care. Bye-bye.